Hello Legacy Sabers, Marsh here. So today we're going to be doing the rational zeros theorem, day 1. You're going to want to have your foldable with you, and then you may need a calculator as well. Our essential question today, how do you solve a polynomial that cannot be factored? So we've looked at how to solve or how to factor a polynomial, right? And then ultimately, since we have factored it, we could ultimately solve it. But there does exist polynomials that on the first time you cannot actually factor it. We need to know how to factor those polynomials. So here's what we're going to do. To find a hint, you're going to become a very educated guesser. You're going to want to find what zero can go into the function that you have in front of you. So to do that, we're going to use the rational zero theorem. Every rational zero has the form of the following: P divided by Q. P is the factors of the constant, and we're going to make a little note. That's the end number, the guy with no x. Okay. And then the factors of the leading coefficient. This is the front number. So what we're going to have to do is we're going to have to generate a list of rational zeros, and then we're going to have to decide which one of them will divide nicely in. Just some vocab flashback. When we're talking about rational numbers, that means we're talking about fractions, we're talking decimals, we're talking integers. Okay, we're not talking no square roots because that's an irrational number, and no i's today. I know, exciting, right? So we're talking fractions, we're talking integers is what we're talking today. All right, so first, let's find the real zeros. First, we're going to look at the factors of the end and the beginning. Also, something to note, make sure that it's in the right order. So you're going to want to make sure that you are in descending order. So you're going to start with the highest exponent and then go your way down. Okay, so we're going to find our P over our Q. P, again, is the last number, so 8 will be our last number. Q is 2, first number, the leading coefficient. Now what I'm going to do is I'm going to come up with all the ways that you can make 8. I can make 8 using a 1, a 2, a 4, and an 8. Right? Those are all the numbers that multiply, that can divide evenly into 8. And I'm also going to do the same thing with 2, a 1 and a 2. Right? Now, keep in mind, here is something to note. All the pluses and minuses also work, because I could divide 8 divided by 2, or I could do -1 times -8, and that would give me a positive 8. So we got to make a little note that we could have plus and minus on the top, and we could have plus and minus on the bottom. Now what we need to do is divide every factor in the numerator over every factor in the denominator. So I'm literally going to divide everybody by 1, and then I'm going to divide everybody by 2. And I'm going to just note that we could have plus or minus all of it. Okay, so I'm going to go 1 divided by 1, that's just a 1. 2 divided by 1, that's 2. 4 divided by 1, that's 4. 8 divided by 1, that's 8. So I've divided every numerator by 1. Now let's divide them all by 2. So I'm going to go 1 divided by 2, that's 1/2. 2 divided by 2, well, that's just 1, right? Don't have to write it again. 4 divided by 2, that's just 2. Don't have to write it again. And then 8 divided by 2 is 4. So these are my, 5 possible, 10 technically, possible rational zeros. So here is my possible rational zero list up here. I just extended that plus and minus. Now what we're going to do is we're going to find the actual zeros of this function. So what these are possibilities from the endless possible numbers that we could use. So to find a rational zero, to find an actual zero, what you're looking for is when you divide, you get a 0 for a remainder. Now, the unfortunate thing that we got to do is literally we're going to play guess. So we need to guess which one of these possible rational zeros is going to give us a 0 for a remainder. I know you're like, really? I have to guess? That's the unfortunate thing. So I'm going to guess 1. I'm just going to put 1 on the outside. I'm going to do synthetic division. Now, if you do long division, if that's the way you like to prefer to divide, you would divide by x minus 1, because that is what would give you a 1. And you would do long division just like I'm going to do synthetic. So I'm going to put a 1 on the outside. Set up my columns. Okay, 2, -5, -14, and 8. Now I'm going to do my division. So I'm going to drop the 2 like it's hot. 2 times 1 is 2, -3, -3, -17. Nope. Frowny face, right? No 0. So now I got to try another 0. So I know it's not 1. Let's try -1 this time. Or, let's try a 2. Feeling kind of lucky, I think, with a 2. Drop the 2. 2 times 2 is 4. That is -1. -2. -6. Whoa. Marsh really messed up there. That's some number. Definitely frowny face there. Let's try -2 this time. 2, -5, -14, 8. Drop the 2. I get -4. That is a -9. That is 18. 4. Ooh, guys, guess what? We got a 0. Whoop, whoop. So these two options, bad ideas, right? So I'm going to retranslate this. This is 2x squared minus 9x plus 4. Because remember, you divided an x out, so you're going to drop from a cubed to a squared for that first number. Now, I want to hope that this factors. So I'm going to go like this. 2x and an x definitely make 2x squared. I'm going to say a 4 and a 1 for my back numbers. So I have an 8x and a 1x. They definitely make 9, -9 if I do a double negative there. Oops. So my two answers right there, because this one you're actually solving. You're actually finding zeros. So I'm going to say x equals 1/2 for the first one. X equals 4. And now you're probably thinking, Marsh, it's a cube. That means I should have 3 answers, right? It is. And you do. Don't forget the guy that unlocked that factoring. So -2. So those are my 3 answers there. Like I said, the unfortunate thing, and probably the most angry thing that's going to really annoy you is that you can only guess. You can really not get it the first time. Now, if you do, you should probably, I don't know, buy a lottery ticket, though you can't. So let's try this one. We're generating our rational 0 list first. So I'm going to try the factors of 9 over the factors of 2, because remember, it's the back over the top front. So then things that can make 9. 1, 3, 9, right? Things that can make 2, 1, and 2. So now I'm going to generate all the things that can make that I can divide. So I'm going to divide all my numerators over all my denominators. So I'm going to get plus or minus 1 over 1, which is 1, 3 over 1, which is 3, 9 over 1, which is 9. Then I'm going to divide all the numerators by 2. So I'm going to say 1/2, 3/2, 9/2. None of those guys simplified into ones I already had, so I have to generate all of them. So all of those possibilities are a possible rational 0. So that's the list we're going to stick from when we start doing our synthetic division here. So I'm going to do my setup here. I'm going to make it nice and small just in case I can't get it very well. X cubed, x squared, x no x. 2, -7. Oh, there's a 0 in there. Careful, guys. Let's try 1. Now remember, if you're doing long division, you would divide by x minus 1. Drop the 2. Get a 2 there. -5. -5, -5. No. Frowny face. Right? We get -4. We get a 4 there. Let's try a -1. Those are my 2 favorite numbers. I'm not going to lie, people. I try those all the time. 2 times -1 is -2. That's -9. 9. 9, -9. Yeah. Now, remember when you're doing synthetic division, I just did it really quick. You do add the inside and you multiply by the outside to get the new inside number. So I'm going to retranslate myself back. I'm at 2x squared minus 9x plus 9. Let's factor that guy. 2x and x. Ways to make 9. 9 and 1, but that's really kind of disgusting if that multiplies by the 2. Let's try a 3 and a 3. So 2x and 3 makes 6x. 3 and x makes 3x. A 6x and a 3x, they can both make a negative, giving me a negative 9. So, solving, I get x equals 3 over 2. That's coming from this guy because I added 3 divided by 2. I get x equals 3. That's from this guy. And then negative 1, don't forget the guy that started it all for your answer. Okay. Ooh, this one's a big 'um. He's got a lot. So we need to generate, oh my goodness, Marsh, all the things that make 105. At least it's over 1. Okay. Marsh needs to grab a calculator for this. 105. Numbers that make 105. Well, 2 doesn't go in. 3 does, though. So we would have plus or minus 1. I'm going to do 105 because otherwise Marsh is going to remember. 3. 3 times 35 is that. 105 divided by 5. That'd be 5 and 21 that go in there. And 7. Does 6 go in? Nope. 7 does. So it'd be 7 and 15. Can I divide 8 in there? Nope. 9. Nope. 10. Nope. 11. Nope. 12. Nope. 13. It seems I have found the full gamut. I'm going to put them in order. Plus or minus 1, 3, 5, 7, 15, 21, 35, 105. Because technically these guys would all be over plus or minus 1, right? Because factors that make 1 are 1. So one of those numbers is going to be the guy that starts us off. So let's try. I'm going to set up my synthetic division here. X to the 4th, x cubed, x squared, x, no x. Got to extend my line there. I'm going to try a 1 on the outside. Okay, drop the 1. 1 times 1 is 1. That's negative 9. Negative 9. Oh, that's maybe negative 1. That's a negative 1. That's 105. Oh, look what Marsh did. She got it on the first try. Whoop, 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 whoop. Okay. Now, if you're looking at this, you're like, well, Marsh, that's x cubed minus 9x squared minus x plus 105. Marsh, that does not factor, right? Because we could group it, but then the parentheses aren't going to matchy-matchy. When this happens, when you start with something that's not a cube, it's very common that you have to synthetically divide again. So you need to get lucky, not just once, but you got to try twice getting the right number to get you a 0. But I'm not going to start with what we started with. I'm going to start with this new one. So I'm going to do this guy. 1, negative 9, negative 1, 105. Notice I'm not using the 0 because that was the remainder. I'm not going to do 1 again because I've already used that 0. Let's try. Ooh, needs to be a big number, doesn't it? Let's try 5. Drop the 1. 5, negative 4, negative 20, negative 21. 21 times 5. Oh, guys, guess what? Marsh got it twice in a row. So I get a negative 105, giving me a 0. This is kind of why synthetic division is kind of nice, because if you had to do long division a bunch of times, it is going to go pretty short, or it's going to take a little longer. So I'm going to translate it. Now, this was a cube over here, so that means it's now a squared. So this is 1x squared minus 4x minus 21. I'm going to set him equal to 0. I now need to factor him. So it'd be x, I think a 7 and a 3 are in order. negative 7, positive 3. So I get x equals 7, x equals negative 3, and then don't forget the guys that started it all. 4 answers for a fourth power polynomial. Now, note, make sure to list all positive and negative factors, okay? Because negatives do, in fact, help us finding that final answer. And then not every zero generated by the rational zero list is an actual zero. So when over here, I have all of these numbers right here, they are not all answers. They're possible answers. It's kind of just giving you like a possible pool to pick from. But here's the cool thing is all of your answers should be in your possible zeros list. That is something that you can use to check your work to make sure you are right. With that, that is the end of our video. I know this is a lot of work and sometimes you just get stuck on the wrong zeros and it sometimes can take you a little bit time to find that zero for a remainder. But you got this. I know you can do it. I will see you later, Sabers.